Hey guys, I'm going to take you through the properties of logs, showing you the proofs of them, and I'll show you some examples, and then please work on your homework. Okay, let's go ahead and get started. We're going to get off with the product rule. Okay, so what we're going to do is we're going to start off with a couple of givens here. We're going to say that b to the x is equal to m, b to the y power is equal to n, and say that b to some z power is equal to m times n. So what I want to do from here is to rewrite these in terms of a log. Okay, everyone, so what we have here is log base b of m is equal to x because b to the x is equal to m. We also have that log base b of n is equal to y because b to the y power is equal to n. And then we have log base b of m times n is equal to z because b to the z power is equal to m times n. So let's go ahead and look at a couple of properties here. Okay, so we're going to first look at what happens when we multiply b to the x times b to the y. We know that b to the x is equal to m and b to the y is equal to n. So that means that b to the x times b to the y is equal to m times n. Okay, well, we know that m times n is equal to b to the z power. So what I have here is a substituted equation. We have b to the x times b to the y is equal to b to the z because m times n is equal to b to the z power. Using our properties of exponents, we can now say this. When we have the same base and we have multiplication, we simply add our exponents. And so we have b to the x plus y is equal to b to the z power. Well, because we have the same exact base, we can say from here that x plus y has to be equal to z, which then gives us, because x is equal to log base b of m, and log base b of n is equal to y, and log base b of m times n is equal to z. Because we have all of that, we can now say that. By substitution, we know that log base b of m plus log base b of n is equal to log base b of m times n. Okay, I know that might have been a little difficult, but we're going to see it again with the quotient rule. So let's go ahead and jump to the quotient rule. We're going to start off with a couple of givens here. We have b to the x power is equal to m, and then we set up b to the y is equal to n. And we're going to say that b to some z power is equal to m divided by n. And so from here, we're going to rewrite each one of these exponential equations into log equations. Okay, so all I've done here is I've rewritten each one of these exponentials in terms of a log equation. So just looking at the first one, b to the x equals m means log base b of m equals x. And so I did that with these other two down here. So we're going to look at some relationships here by first messing around with the b to the x and the b to the y. We're going to see what happens with b to the x divided by b to the y power. Well, we know that b to the x, that's equal to m, and that b to the y power, we know that's equal to n. So b to the x over b to the y is equal to m divided by n. So from here, let's look at what m divided by n is. Oh, m divided by n, that's actually equal to b to the z power. So let's make a substitution. Okay, so here we are with the substitution. B to the x over b to the y is equal to b to the z power. Well, using our properties of exponents, when we have one base in a numerator and the other in the denominator, we can subtract the exponents. That comes from our laws of exponents. We can say that b to the x minus y then is equal to b to the z power. Well, we have the same base here. And because we have the same base, we can say that the exponents then have to be equal to each other. X minus y, that it has to be equal to z. And we have x equals log base b of m, and we have y equals log base b of n, and we have z equals log base b of m over n. So we can use substitution to write our quotient rule. And here we are at the proof of our quotient rule. Alright, we got one more that we're going to look at, which is the power rule. And this time we're going to start off with a logarithmic equation. And let's go ahead and take log base b of m equal x and rewrite it in terms of an exponential equation. Okay, so we have b to the x is equal to m based off of log base b of m equals x. And what we're going to start off with here is we're going to start off with actually we're going to start off over here in the black. We're going to multiply both sides by a c. We're going to multiply both sides, not by a c, we're going to multiply both sides by a p, sorry. And so we have p times log base b of m is equal to p times x. Alright. Alright, so we're also going to mess around with the right side over here. What we're going to do on the right side is we're going to raise both sides to the p power. So I'm going to raise m to the p power, and I'm going to raise b to the x to the p power. Alright, so let's look at what happens with this when we raise to the p power. That means that we have b to the xp is equal to m to the p power. Okay, and from here we're going to use logarithms to rewrite this exponential equation. So we're going to say that log base b of m to the p power is equal to this exponent over here, x times p. Well, don't we have an x times p? We sure do. We have x times p over here, or p times x, which is the same thing. So based off substitution here, we can say that p times log base b of m is then equal to log base b of m to the p power. Alright, so I do want you guys to be able to prove each one of these rules. And so in a test-like scenario, I would start you off with something and tell you to show me the rest of the proof. But let's go ahead and look at some examples where you'll actually use these rules in this homework. So let's jump to the next page. So some of the problems that you're going to deal with are going to have you take a single logarithm and expand it into multiple logarithms. Let's get started by looking at part A here. We have log base b of x to the second power times the square root of y. So the first thing that I notice here is that I have multiplication. Multiplication tells me that I'm going to be using the product rule. Remember, log base b of m times n is equal to log base b of m plus log base b of m. So I can break apart this log into two logs added together. Okay, so we have the two logs separated, and from here what we're going to do is we're going to use the power rule, the last proof. So what that means is I'm going to rewrite that square root as a 1/2 exponent. Okay, so now we have a 1/2 power. And now we can use our power rule to pull these exponents in front of the logs. And so we have 2 times log base b of x. And that is expanding because that means log base b of x plus log base b of x. There's two of them. So that is expanding by using the power rule. Okay, so we're going to use the power rule to pull that 1/2 in the front there. So we have 1/2 times log base b of y. And that's it. We've expanded as much as possible. So let's look at this next one here. This next one here, part B, we have log base 6 of the cube root of x divided by 36y to the 4th power. We're going to go ahead and use the quotient rule here. When we have division, it means that we're going to be using our quotient rule. So let's look at breaking this apart. Okay. Remember that log base b of m divided by n is equal to log base b of m minus log base b of n. So I'm going to use that property to break this one apart. Let's look at it. Okay, so I've broken apart part B using the quotient rule. And so from here, let's go ahead and deal with this right side over here. What I'm noticing is I'm going to have to rewrite this cube root into a 1/3 factor. And I also see over here that I have 36 times y to the 4th power, which actually is the product rule. So I'm going to have to break apart that log again. So let's go ahead and deal with the right-hand side here. I'm going to do a couple things at once, okay? Alright, so now we have log base 6 of x to the 1/3 minus the entire quantity. And notice that I put parentheses around it because this represents, inside the parentheses, it represents a single quantity. So we need to have the negative in front of parentheses because these two logs represent that single log up there. So the parentheses are very important. Minus the quantity log base 6 of 36 plus log base 6 of y to the 4th power. So let's do a couple of things here. Let's use the power rule, and also let's evaluate log base 6 of 36. 6 to what power is actually equal to 36? 6 to the 2nd power is equal to 36. So I'm going to write a 2 right there. Okay, so I've used the power rule. I've evaluated the log base 6 of 36, and I distributed the negative as well, and I can't expand anymore. That is that. Right now we're looking at how to expand some logs. Let's look at how to condense a log. That's the next page. All right, so we want to write as a single logarithm. We're going to go ahead and get started with part A here. First thing I notice, I have logs separated, same base, separated with addition. So that tells me right off the bat the product rule. Before I can use the product rule, I need to use the power rule. So I'll rewrite using the power rule to start. So here we have the power rule, and from here I can use my product rule to. We have log base 10. When the base is not there, it's a base 10. Log base 10 of the square root of x times x minus 1 to the 4th power. Okay, let's look at the next one here. We're going to look at natural log, ln. Remember, that's a log base e. And I notice right away that I have minus, which means quotient rule. However, before we can use the quotient rule, we have to use the power rule. And so let's go ahead and rewrite using the power rule and then the quotient. So here we have rewritten using the power rule. Now let's finish off by writing with the quotient rule. And finally we have a single log, the ln, log base e of x plus 7 to the 3rd divided by x. All right, one more to go, part C. We have a couple things going on here. We have subtraction. We also have addition. We have our power rule that we need to use first. Let's go ahead and rewrite C. Okay, so here we have part C rewritten using the power rule. So from here, let's go ahead and use our quotient property, then our product property. We go from left to right. Okay, so we have our quotient property here. And then finally, we're going to end this by using our product. Alright, you guys, see you in class. Ask questions.